Each morning I get up, I die a little. Can barely stand on my feet. Take a look in the mirror and cry, Lord, what you do to me? I spent all of my years in believing you, but I just can't get no relief. Lord, somebody, ooh, somebody, can anybody find me somebody to love? Yeah, I work hard.
This is Dr. Ed Park from Recharge Biomedical, and today we're going to talk about AIDS and aging. And what we see here is a picture of Freddie Mercury in his prime, the lead singer and songwriter of Queen, who wrote all those wonderful hits like We Will Rock You and We Are the Champions. And then on the right, before he passed, he looked like a much older gentleman, almost ethereal in his appearance. And so the question arises, what is the relationship with advanced AIDS, which of course he had, and aging? It all comes down to the thymus. This is the Greek spelling. We spell it with a U, but the thymus is this gland in the middle of the breastplate here. And it's a homonym, I guess, in Greek to the soul, the thymos, but there's also, we think the derivation is like the thyme plant. So that's a little unclear. Some people thought that the seat of the soul is the pineal gland, and if you see the circadian rhythm webinar that I did, you might agree with that as well. But as far as Galen was concerned, who was a famous physician who literally wrote the book, of course borrowing on ancient traditions before him, he said that it was larger in infants relative to the body, and he thought maybe it purified the nervous system. Who knows? But again, Ben Franklin thought the testicles were somehow related to breath. So, sometimes you take a shot and you're not right, but I guess you could argue that it does purify the nervous system in that it prevents aging. The T in thymus is for T cells, which is victimized during AIDS. And the B is for bone, which we won't be talking a lot about, but bone marrow is also part of the adaptive immune system. So what happens with B cells is they originate like the T cells in the bone marrow, but they go to the spleen. And there they're processed and become ready to hang out in the lymph nodes primarily. And in the lymph nodes, they can differentiate into plasma cells, which are these little antibody factories. And they can also differentiate to memory cells, which is the ability to remember that a bad thing like polio or whatever it is, tetanus, sometime in the future. Plasma cells go to the mucoid-associated lymphatic tissues, so they coat the airways and such with antibodies to prevent you from getting sick. We're familiar with the circulatory system, maybe even the nervous system. Of course, if you have the circulatory system, you'd have a heart, veins coming back, arteries going out. The nervous system, you'd have a brain and a spine, nerves going out and coming back in. But with the immune system, we don't talk about it too much, but this is a system as well. And the system is comprised of these lymphatic channels, which follow the course of the veins, roughly. And the center of this would be, well, it's off-center here, up towards the thyroid. It's actually closer in the breastplate, but a good drawing nonetheless. So we have the B, bone marrow, spitting out bone marrow cells, and those go to the thymus here and go to sort of like a cellular West Point. So what's going on is that the body gets blood out through the arteries and the capillaries to the tissues, and when the blood cells, white blood cells, these little troops squeeze through the capillaries, they go through all the tissues and patrol, and they come back through like a passive like a drain system, sort of like rain gutters, and these are the rain gutters. So the lymphatic is not directly connected to the circulatory. It takes in the fluid sort of like a sponge from your tissues. All right, let's look at here on the right and see what happens with thymic. This is important because AIDS is about T cells and AIDS is aging. So as we age, our T cells deteriorate. So what is normal West Point graduation series here? The thymocyte comes from the bone marrow, and it needs to be positively selected. In other words,
it has to be able to recognize friendly cells, so it wears a uniform called MHC, major histocompatibility complex. That way it can tell friend from foe. In the deeper part of the thymus, or the medulla, the opposite process is occurring. In other words, cells that are overly aggressive towards the self are negatively selected and they are weeded out. Failure to be weeded out may be related to a higher incidence of autoimmune diseases like arthritis, lupus, eczema, etc.
when you graduate the thymus, you're able to recognize friends but not be overly aggressive and become a clock tower shooter or something like that. So we have the CD4 and the CD8.
So what do we mean by CD? CD stands for cellular differentiation, and they're proteins that appear and disappear from the surface of the T cells, allowing for us to identify them and to categorize them. When they start out, T cells have both the CD4 and 8 markers, but by the time they graduate out of the cellular West Point, they've been selected to be either CD4 or CD8. CD8 cells are also known as killer cells or cytotoxic cells because they've been trained to recognize and kill things like viruses. CD4 cells are called helper cells because they help to remember past threats and help to rally new expansions of killer cells as well as antibody-producing plasma cells. So let's take a look at the immune system in action, like crime fighting on the street. The macrophage is the antigen-presenting cell, the one that comes around like Pac-Man and munches up the bad cell, and it presents the antigen on the surface in the major histocompatibility complex 2. So that little tulip-like thing has a piece of your, let's say, herpes virus or HIV, and it goes up to a CD4 cell and says, help me, you're the helper. So they recognize each other first of all because they're both wearing the MHC1 uniform. The specific tip or NARC of the antigen presenting cell gets the dispatcher or the T helper cell excited, and it clonally expands. It sends out the cops and it produces either T cells or B cells and these cytotoxic macrophages and killer cells.
So this is the last CD that we'll talk about. It's CD28. It becomes very important when we talk about immune senescence, or the idea that the immune system ages. So let's talk about what the T cell activation entails. Your immune system is hopefully like blank keys. If you have a lot of keys that are already cut, let's say they're all for herpes and you got none for AIDS, you're going to die of AIDS pretty quickly. So you need to have a bunch of uncut keys, blank keys, and that's what the T cell is, the adaptive naive T cell, also the undifferentiated B cell. So B for bone marrow, T for thymus. So here's a antigen presenting cell. This is the NARC. It comes in and it tells the dispatcher, if you will, the naive helper cell, hey, we got a problem. And then if the signal is received, then it'll expand clonally. It'll multiply a bunch. So what does that look like? It's a major histocompatibility 2 plus the T cell receptor. This is the sort of, I kind of called it eye contact. It's like this is how they recognize, hey, let's see if you're part of the team, And then the signal 2 is the CD28, which is on the naive T cell, and the B7 of the antigen-presenting cell. That's the secret handshake. That's the magic moment where it says, yeah, we're friendly, but hey, we're going to kill. We're going to do something really sort of like a Manchurian candidate, or it's gonna say, now we know who we need to kill. So it'll proliferate and it'll express, let's say, human herpes virus ability to kill. And so like thousands upon millions of these will reproduce. And of course, what do they need to reproduce? Telomerase, yes, which is upregulated once this magic moment occurs. If you have a resting antigen-presenting cell without the little B7 flag going out, it's mellow, it hasn't seen any problems, it doesn't want to get anyone too excited. So there is no response. Interesting thing happens. IL-2 is one of the cytokines that allows for this incredible alarm and proliferation of cops or soldiers. What happens with the natural balance of T cells is when they're overexcited, you don't want a cascade. You don't want a campfire to become a forest fire. So they start to express this antigen called CTLA4. And if the activated antigen-presenting cell connects with this is like the cool-out signal. So it can also have the heat-up signal with the CD28, but the cool-down signal. So there's a built-in feedback loop. And so if the B7 hooks up with there's just a ton of these specific for herpes, then it starts to actually cool down and turn off. And this will cause the T cell response to blunt and not secrete interleukin. So there's downregulation. So there's a built-in ability to quash the T cell response, we hope. Okay, very technical, but again, super important to understand what we're going to talk about. So again, the thymus is the T cells, B is the bone marrow cells for the antibody-producing cells. The immune system is this kind of one-way passive circulatory system, and the thymus needs to learn the self and not to be overly aggressive. And then you have this clonal expansion when the antigen, of course, now we know it's the CD28 that's presented alongside the major histocompatibility complex of the T cell antigen, and expands to send out the riot police. Okay, so what causes AIDS? AIDS is caused by HIV. And of course, we know that the CD4, the helper counts, are particularly affected. This tulip-looking thingy is the HIV. I guess HIV virus would be redundant, like ATM machine. But these are the docking proteins here. This is the glycomembrane protein. None of this really matters. All that matters is that you got 2 copies of the nasty bugger's RNA, and then you have this reverse transcriptase. So why is this important? What's going to happen in the life cycle is the HIV is going to dock on those docking proteins and squirt into the cytoplasm of the T helper cell. And then what kicks in is a reverse transcriptase. Now, important to know why they call it reverse. Usually the dogma of cellular genetics is that you have your DNA, right? You copy into RNA, which is single-stranded. The RNA leaves the cytoplasm, and it codes for proteins. Well, in the 1970s, they figured there must be a reverse transcriptase in these RNAs, so they knew that these HIV or these, let's say, these RNA viruses were a single strand. How could that even be alive, and how does it affect us? Well, it does so by taking its RNA, and it brings its own reverse transcriptase. So it reverse codes from RNA into DNA, which then becomes double-stranded and integrates, splices right into your DNA, and that's why you get a problem. That's why you can't ever get rid of a cold sore, because it's part of you now. It's not going away. Now, that's the assimilation. When it needs to make more copies of HIV, it will export its RNA, and just like the central dogma, it'll make proteins, its own proteins, and it'll reconstitute another virus using the cell, the host cell, and we're ready to go. Interestingly, a reverse transcriptase is exactly what telomerase is. It's not bad. It's basically taking the template of telomerase, which is the 6 base pair TTA GGG, and it prints 6 at a time, boom, 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 and that's how we lengthen. So the telomerase in every stem cell is also taking 6 base pairs and just cranking them out. and that's this interesting study out of UCLA Geffen School. It wasn't even the Geffen School at that time, in '96. It's by the leading researcher, I think, in immune aging, Rita Efros. And we actually use her lab to measure our own clients' immune health, which we'll talk about later. Also, you can see later on the list is Cal Harley, who was the chief science officer of Geron and really the luminary who's at the center of all this telomerase research as well. They found that the killer CD8 killer but CD28 negative subset in HIV was increased. So what does that mean? CD28 is a burnout. It's cut. It's not naive. It's already specific and it's exhausted. So what they found when they looked at the telomere lengths, and remember, humans usually start with 10,000 at birth, 15,000 at conception. So they were shorter in HIV-infected cells. So, and this mimicked what they saw in people who were 100 years old. So they thought, aging, AIDS, maybe there's a connection. A study 3 years later looked at the CD4 or helper, so-called helper fraction, found the same thing. They defined it as less than 5,000 base pairs on the telomeres, or they called them old, and they in HIV-infected patients or advanced AIDS with T-cell counts less than 200 per cubic millimeter, they found that it was very significantly decreased, the length, and that the number of critically shortened ends were also increased. So more proof that T-cells, both the 4 and 8, are burned out, exhausted, or somehow aged. This is another study 3 years later looking at, by Rita Efros again, now is the David Geffen School. And she looks at the way CD28 expression changes following the same antigen stimulus. So let's say you have CD4 and 8 cells and you expose them to human herpes. First time they both get really excited. They have a lot of telomerase activity so they can reproduce and not get older. But the CD8s burn out faster than the CD4s for some reason. When I say burn out, they burn out, but it's known that in advanced AIDS, they outnumber the CD4s. So what's going on there? The sense-static phenotype, or the sense-static thing, is talked about in the stem cell podcast we did with Michael West. But suffice it to say that sometimes cells become grumpy old men. They don't kill themselves like healthy warrior ninjas. They just hang out. And so these CD8s are senescent, and they just persist. But also, remember, their role is to kill the younger CD4. So if you stochastically let the grumpy old men hang out, they will kill off the younger ones in AIDS, and that's why the balance shifts strongly to CD8 over CD4.
Just killed a man, put a gun against his head, pulled my trigger, now he's dead.
And there could also be a stochastic thing in the ratios at which and the rate at which they reproduce. I don't know the answer to that, but I do know empirically that when you get advanced AIDS or aging, the CD8s, these grumpy, burnt out CD28 negative ones, outnumber. Finally, the thing that ties it all together, we could say clearly that AIDS is like causing aging. And now that we see that HIV individuals, people who may have gotten infected as early as the 80s, have lived longer, but they show comorbidities not associated with HIV, but just from being old. So they become afflicted with more heart disease, dementia, frailty, arthritis, and they're positing maybe it's because of a dysregulated systemic inflammation. Interesting thought. So again, the key here is the HIV patients became pro-jerk. They aged quicker, like our friend Freddie Mercury. So it's not just that you're more susceptible to aging, but something about immune senescence causes you to become older. And this is all starting to sound intuitively true from what we know watching friends and relatives get older. Another thing we know quite clearly is that stress causes aging. How many times do we see people with life stresses, loved ones afflicted with cancer? They either get sick or they get cancer themselves, and it's because of a breakdown in the balance of the immune system. Here's a mechanism described that when T cells are exposed to cortisol, and cortisol is the daytime stress, flight or fight response hormone, also very high in states of anxiety and depression and helplessness, that you reduce directly the telomerase activity, both during your final stimulation and secondary stimulation. So the response to immune challenge and the cry to rally is blunted. Hence, we have that stress inhibits immunity via telomerase inhibition somehow. I mean, it could be overly simplistic, but this is why we get cold sores if you, and 2/3 of the population have been exposed to the virus upstairs in the lips. So that's why stress will cause cold sore. And that's probably why extreme fluctuations in weather also cause illness, even though quote-unquote science hasn't recognized that. It's clearly true. You get a cold from going out with wet hair and coming into a hot room and switching around. It must be cortisol mediated. Let's step back to 10,000 feet and look down and see what we're talking about. So I made this slide to indicate that we probably are looking at just one disease. So other webinars talk about what replicative senescence is. I won't flog that horse, but suffice it to say that the telomeres shorten, and when they do, the DNA can be damaged because it's improperly connected, and then they're torn apart into fragments. When that happens, apoptosis occurs, sparing us from these outer complications. This third ring should really be failed apoptosis. When you get failed apoptosis, or this ritual harakiri or seppuku, you end up with grumpy old man stem cells, dysfunctional, damaged, even cancerous stem cells. What does grumpy old manism or senescentic phenotype look like? Well, in the arteries, it causes stiffening. Okay, so what's the adaptation to stiffening? More stiffening. Because what you have is like a garden hose. If it's all calcium deposits in the hose, the only way you can get the water to your car is by squeezing it further. So hypertension is not actually, in my opinion, a disease. It's an adaptation to stiffer, less contractile, and more gummed up arteries. So you just need to squeeze the hose. In the pancreas, you get these insulin-producing cells. When they go dysfunctional, you get diabetes. Obviously, you know, the female ovaries shut down, wrinkles, and of course, this is general, but blood cells, when they deteriorate, you get the immune senescence, but you also get things like myelodysplasia, which is myelodysplastic syndrome. I think there's a famous newscaster, Robin, who it's pretty clear to me that myelodysplasia is just the same DNA replicative senescence failed apoptosis process in some bone marrow cells. So again, everything is aging, everything is shortening of the telomeres. So when we talk about AIDS, AIDS stands for Acquired Immune Deficiency Syndrome. Now, when you talk about the AIDS, then that is HIV 1 and 2. When you talk about lowercase AIDS, that's aging for us. That's everyone's AIDS. So we acquire an immune deficiency as we get older, and it's a syndrome. And what does that syndrome look like? This is from a paper out of Italy showing that persistent CMV infection in the elderly has a profile, has a syndromic quality to it. So I'll post a more legible version of this in the final edit. But what does an old dude's or lady's immune system look like? Well, just like HIV, you have a lot of CD8s versus CD4s. You don't respond well to mitogens. In other words, a signal comes in that there's a threat. You don't respond well. You don't expand thousandfold and overwhelm the invader. You just can't. Probably because telomerase is not active, CD28s are burned out, who knows. And again, there's a high level of CD28 negative, meaning not naive, meaning overly experienced. The B cells are also burned out. There's a lot of CMV exposure, and that the veterans, if you will, are CD28 specific for CMV. If you go to the VFW hall, they were all in the CMV wars, meaning the ones that are still hanging out talking about, combat are CMV specific. This is why we get old and why other people are at particular risk for dying from infection. Jack LaLanne died January of 2011, and here's a fella who had all the good karma in the world with regard to exercise and diet, and he probably could, outperform the vast majority of 30-year-olds at 95. So he figured, it's just a flu. I'm not going to go to the hospital or cold. And of course, because there were no ninja troops that were all just grumpy old men, or maybe none at all, he didn't have an immune system, and it quickly overwhelmed him, became pneumonia, and he died. And that is what we need to understand as we get older being in the 7th and 8th decades probably.
I've had my share of sand kicked in my face, but I've come through. It's a
We are the champions, my friends.
And we'll keep on fighting till the end.
We are the champions. We are the champions.
No time for losers, 'cause we are the champions.
When you look, this study from the Lancet by another collaborative TA scientist, Richard Cawthon, over the age of 60, people with short telomeres had bad survival. But what's borne out is that, there's some higher heart disease, but in general, it's infection. He's saying 8-fold higher, 8 times the risk of death for infection over 60. So now that we've learned what we've learned about how the immune system burns out from overuse, copying, and challenges, we see why Jack really died of his lowercase AIDS. There was nothing left. There were no blank keys left. Okay, so the Roman Empire fought different enemies throughout its heyday. We got the Angles and the Saxons, the Franks, the Goths, the Visigoths, Ostrogoths. All the Goths are kind of Germanic. Huns coming from the steppes, and the Vandals coming from what used to be Phoenicia, I guess, or whatever. Suffice it to say that Rome was always besieged. Now, Rome, let's say, I'm not saying they were the good guys. Maybe they were, maybe they weren't. But they had a way of assimilating other cultures, building infrastructure, political consciousness. And so when they started to incorporate barbarians, as we call them, or Goths, into their armies, it became a mercenary army, and they really didn't have the same strength, if you will, to overwhelm. They didn't have the strong leadership. Everyone was sort of Byzantine, if you will, and bureaucratic and corrupted by money. And certainly some people have said the introduction of monolithic Christianity had something to do with it. But suffice to say, enemies became incorporated into the body of the Roman Empire, and there was really no way to survive. These are the enemies within us. We share Kool-Aid at the age of 8 with our cousin. All of a sudden, we've got herpes, oral herpes for life, as 2/3 of us do, and it gets incorporated into the neurons of our spinal cord. It's never going away. genital herpes, which is downstairs, HHV2. These are all cousins, by the way. They're all closely related. HHV, human herpes virus 3, is shingles or chickenpox. Same thing. Who gets shingles? People who are old. And old being a proxy for immune compromise. People who are extremely stressed, cancer or chemo. HHV4 is the Epstein-Barr virus. This is the kissing virus, chronic fatigue. Also one that is highly implicated in immune senescence, along with the close relative 5, CMV. Again, we saw that Italy study where CMV is just tearing up, like the Goths, is just tearing up the immune system. Roseola is HH6, 6th disease. There are, they numbered them 1, 2, 3, 4, and 5, 6. 5th is parvovirus. It's just a old clinical saw from pediatric days. Pityriasis is 7. That's a rash all over the body. A lot of people think they're allergic to penicillin because they took penicillin when they shouldn't have, and they were going to get this rash all over their body anyway. HH8 is Kaposi sarcoma. Now this is an interesting one. I remember back when I was in medical school in the mid 80s. This was one of the hallmarks from the Center for Disease Control. They saw that young men were getting Kaposi sarcoma, which was generally only described in older Mediterranean gentlemen of compromised immunity. So young men getting an old man's disease, and now we know attributable to this human herpes virus. It's all seeming to sound very suspiciously related. Now, when we look at cancer, I did this mashup to help me kind of understand what cancer was and how it's currently being treated. At the base, I think the most effective treatment is ignored. Everything below here is ignored, which would be to protect the telomeres, keep them from shortening so they don't get inappropriately connected and spliced and damaged. Now, every cell is endowed with the p53. This is the self-destruct mechanism in the Mission Impossible tape. So, again, the Volvo, the guy with 2.6 million miles, he's preventing damage. He's smart. That's the best. If you got damage, you can kill yourself with the self-destruct mechanism. The tippy top of this underwater or underground pyramid is the natural killers. There are cells, natural killers, but also, to an extent, the adaptive immune system, which is made to destroy unfriendly characters. So here's the riot police. So, unfortunately, in 2012, all we have is the stuff above, which is the poison, zap, and cut. Cut being the best. If you can cut it out completely, it hasn't spread to the nodes, you're cured. If you can irradiate it locally without too much damage, that's good too. But chemo is like dropping a neutron bomb at 10,000 feet. Not so good. That's killing everything, good and bad, including immune systems, which are stem-like and rapidly producing. So let's close here on the final bit of data. People are always saying, well, what's the data? Well, I haven't had time to change my website. Unfortunately, I'm fighting off my own barbarians. We just got hacked. It's okay now, but some Russian site injected code. So I don't have that much time to be webmaster, but this is one of the studies I would put up there if I had the time. And this is from who else but Rita Efros and Cal Harley. And this looked, I believe it's 2008. They took a molecule discovered by Geron, a telomerase activator, and they gave it to HIV-infected T cells. So this should have been big news, but of course no one can make money off of a natural compound extracted, so this died on the vine. But what are the results here in this very elegantly designed study? They looked at CD8 killer cells, and when you put this TAT2 in, the populations could double longer. This is without DMSO as control, and this is with they could double longer. They're more viable. The telomerase activity as measured by the TRAP assay, or the ability to write new 6 base pair ends to a stimulus. If you look at DMSO, it's the white, it's pretty low. It's less than 1. But the histogram for TAT2 went up. So there was telomerase activation in real time. This is 15 minutes, 30 minutes, 60 minutes. So that's intriguing. Further, they went to find out that the CD8 cells, here are the actual wells that they're examining, the ability to produce active CD8 function, meaning interleukin-2, as we discussed, was enhanced when you got the TAT2 at a micromolar concentration more so than at a nanomolar. So 100 increase didn't cause 100 increase in terms of function, but it was proportionate. We like to see that when we try and establish causation, that more is more. It's not just haphazard and random. So it did increase the CD8 functioning by taking this, by introducing in vitro this TAT2 molecule. And the mechanism, which it's a little hard for you to tell here, but if you look here on this histogram to the lower left, DMSO is control. That's the white. DMSO with a telomerase inhibitor, flat. TAT2 with a telomerase inhibitor, flat. So that they're trying to imply and also infer that it is the telomerase activation, not another related or unrelated or unknown quality which causes it. It is the telomerase activation per se, because when you put a blocker of that, you don't get the increase shown in the black histogram. Here is a study done on me and other people. I started in November of 2007, and of course it took about a year to get 100 people on this, and it was quite expensive to do as well. It was $25,000, the initial cost. So they went data mining. I mean, let's not kid around. This is not randomized controlled study design. This is looking at the data and seeing what shakes out. And so, of course, that's not the greatest methodology for biostatistics, but what they found, nonetheless, was that when they broke down, with the help of Efros's lab, the CD28 negative cells, those are, again, the grumpy old man burnt out killer T cells, what they found was that there was a significant decrease in these at 3, 6, 9, and 12 months. So there was a decline in the percent of senescent T cells. There's a 1% decline, a 4% decline, 8% decline, then another 7.5% decline, I guess, off the previous level. The natural killers, which are also indication of immune senescence, meaning if you have no innate adaptive system, the natural killers step up and they become overrepresented. That also decreased with telomerase activation, TA65, via the patent protocol. And that most of these occurred in people with CMV seropositivity, meaning people who had been fighting the Visigoths, or the CMV, the culprit, which is of all the HHVs, perhaps most related to immune senescence. And that there was a significant reduction in the percentage of short, they define it as 4,000 kilobase pairs of telomeres. So what does that mean? It means that if you took TA65 in the first year, your telomeres didn't get longer, shorter on average. No, that was not a slam dunk. But what did happen was that you had fewer of these burned out grumpy old men, and fewer of the killer T cells had extremely short or critically short telomeres. And so the study that follows up on that would be Blasco giving the TA to mice now. And what she did out of the Center for Cancer Research in Spain was that she gave TA65 to mice, and she found that it also lengthened the telomeres, but more importantly and predictably decreased the critically short ones. So she engineered these mice to become prematurely aging. Current mice are actually been selected for being freakishly resistant to aging by virtue perhaps of their long telomeres. But she made mice more like people, and then she engineered some to have TERK. Now, TERK is telomerase reverse transcriptase component. I'm sorry, RNA component. So that's the template to make the DNA. That's the instead of the TTA-GGG, it would be the AAT-CCC. So this would be like the analogous to the template or the HIV genome. So you had to have TERK. In other words, for this effect to occur, you needed to be using the key to the engine, the TERK. It wasn't from some other esoteric or alternative lengthening means. It was mediated solely through TERK. So if you didn't have the key to the engine, the TERT, didn't happen. But if you did have the key TERK positive in one of the copies of it, then you would get a similar effect. And so the critically short telomere fraction disappeared, and lo and behold, as evidenced by a different study design out of Harvard with mice, they got younger. They didn't just not get older. They got less diabetes, osteoporosis, skin problems, and neurological issues in the Harvard study. So you can make mice younger, which is what we've been doing to people, we think, even longer than these lab studies. So what's the step for you? You can come in and we will draw blood, send it to Ephros Lab. This is not available for commercial use, but we've been using it for 4 years now, and we'll measure your fraction of burnt out cells. The cost of that, I think, Susie, was $400? About $400. And then the telomerase is the leukocyte telomere length. We can either do that to Canada or we can send it directly to Glasgow, who has developed this new assay that will measure the critically short, or less than, she calls it 3,000 kilobase pairs. And that will give you an idea of how damaged those are. And it's been my experience that I didn't recommend measuring just the average length because it could go up, down, or sideways on TA, but I believe that the initial study with the first 100 patients, and then the mice study, and then the upcoming collaborative study for randomized control human subjects in Spain will show that the critically short telomere fraction is decreased, meaning you're able to cause the damaged cells to kill themselves, I do believe. So what's VisioAge testing? VisioAge testing is this suite of tests developed by the original collaborator, Dr. Joe Raphael, out of New York, and so he's quite the expert, and he came up with charts based on over 100 subjects, and he's able to draw normal curves or bell curves for people and infer using a multiple fit regression model your real physiological age, or physio age. So the more of these measures you have, the better. If you come in at this time, it's complimentary. We'll do your cardio age, measure your arterial stiffness, your pulmo age, your lung youth or age, QTO age, meaning we have a very advanced elastometer to measure how elastic your skin is. Neuro age can be done on the internet. That's just a memory and cognitive processing test. So we plug in the 1, 2, 3, 4, 5, and 6 variables, so we come out with a composite. But more importantly, you follow each of them individually, and it's been our contention and our experience that if you take TA65, oftentimes there is an improvement in many of these age-related indices. So I look at it as a value proposition. If you're going to spend a lot of money on the supplement, you're going to feel good subjectively, but eventually, as described in the Frequently Asked Questions podcast, you get used to it, and you get to a healthier place. You figure, hey, I don't need it. But if you take the time to get these tests and objectively measure, then what's been the imperceptible decline of your body and systems will have a number, and its backing out will also have a number, and you can then really put a true value on how much younger you've become, and therefore I think it's helpful. So we've made the decision to not have any barriers. We don't pass along any markup at this time, although we reserve the right to in the future. So all the testing is complimentary and or given to you at cost. So why do we talk about this? Well, there was a study I saw about a month ago that showed that children with HIV had shorter telomeres, and that was associated with a high viral load. So just got me thinking. I've been wanting to do this webinar for a while because what I've noticed in patients mostly is that they don't have colds or flus, or if they do, they have these strange versions of them that just kind of linger in the throat for a day and never blossom. And that could represent an improved adaptive cellular immune system. My friend's dad, who had the brain cancer, he complained at about 3 weeks that he was getting a runny nose. And in interviewing him, it turns out that he'd had allergic rhinitis in the spring throughout his whole life, which was significant, but that by virtue or by vice of the last 2 years of Temodar, which is a chemotherapy, he never had hay fever. So the fact that his hay fever occurred suddenly and dramatically, to me, implied a recovery of the immune system. And of course, the pollen passed, and he took some Claritin, and it worked out well for him vis-a-vis the cancer. At this time, 5 years out, he has no evidence of his advanced astrocytoma. There's also stabilization of cancer. There's low rates of new cancers, but the people with advanced cancer that have gone on, they have not progressed. They've tolerated their chemo very well. And to this day, I know of only 4 people who've developed cancer, or perhaps more accurately have been diagnosed with cancer, because it could have been pre-existing, while on TA65. And I really think that's the case. And that numerator over a denominator of well over 15,000. Now, granted, I don't have access to all those patients' records, and the number is undoubtedly higher, but it's still unusually low for a group of median age 60 plus. And I have several patients with Hep C, which is a overwhelming viral threat, and they seem to be stabilizing as well. Having said that, TA is not FDA approved to prevent or treat any disease, and so this is purely anecdotal, although coming down the pike, I hope, will be, of course, the critically short telomere study from TA Sciences and Maria Blasco. But again, I challenge anybody who is a clinician or a research scientist to do a study design for any of these 36 topics of that I've done, and I feel that with a very low statistical power required, you'll be able to show statistically significant changes using a good placebo-controlled double-blind study design. Okay, finally, let's do the raffle. Young Ho Kwek says that flu and cold appear to be less frequent, and that's certainly the case. I haven't gotten I've gotten like a mild, like scratchy throat in the last 5 years, maybe twice, but that's it. And I would say even in times of stress, cold sores now in year 4 just don't occur, which is nice. Okay, good. Any questions? It's a plausible theory, one with a lot of experimental evidence. It makes sense to us that we run out of immunity, and I hope I've somewhat convinced you that this is reversible with telomerase activation, probably by an apoptosis mechanism.
Come on, keep yourself